Problem guys, so today we are going to start with the second phase of this memory and data storage. Now we do have an activity over here that says an image is 1200 pixels by 1600 pixels. So they are asking you to calculate the total number of the pixels in the original image. So what are you going to do? You are just going to multiply 1200 by 1600. So you will be getting the answer in the pixels. Remember that you guys are not allowed to use the calculators at all. So by multiplying 1200 into 1600, you will be getting the answer 192 and then 4 times 0 pixels. Now they're saying the number of the bytes occupied by this file. So always do remember that if it's a colored image, so it will be getting 3 bytes for single pixel. The reason behind is one for the red, one for the green, and one for the blue, as we are having 3 basic colors R, G, and B. So what you need to do, you just need to multiply 192 4 times zeros by 3, and you will be getting the final answer. So that will be 576 4 times 0 bytes. Okay. Now moving ahead, is this point clear? Rayan, clear? Now the third part, the file size of the JPG image in kilobytes. The original image was reduced by the factor of 8. Now reduced by the factor of 8 means that you have divided it 8 times. Okay. So first of all, what you can do, you can just simply convert bytes into the kilobytes. So to convert bytes into the kilobytes, you need to divide it by 1000. So it will be 5760 kilobytes. Now you can easily divide by 8. So dividing 5760 by 8 will give you the answer 720 kilobytes. Got this point? Okay. Similarly, we do have the second phase as well, or you may say the part B as well. You can attempt this part at home, and if you're finding any kind of difficulty, you may concern it with me. Now we're moving ahead towards the next part, and that next part is regarding the secondary storage devices. So when it comes to the secondary storage devices, so we do have 2 different types of secondary storage devices. One is the HDD, the hard disk drive, and the other one is the SSDs. Now when it comes to the HDDs, so just let me draw us. Okay. Now it's a hard disk drive, and in between there are magnetic material in it. Okay, and the data over here is stored in the form of the platters. Platter means small parts that are basically stored over here. Okay, the small memory locations. Now this disk rotates in the clockwise or in the anti-clockwise direction around 7,000 times a second. It makes one another movement that is from the center to the corner and back from the corner to the center, and that is approximately 50 times a second. These are quite sensitive sort of the material. The reason behind it is because these are the magnetic material, and if the magnetic field get disturbed, so they are unable to store the data. Okay. Now, apart from this, there was a major issue in this. Now, what is the major issue? That major issue was regarding the latency rate. Now, what do you mean by the latency rate? Latency rate means time to access the data. So they are taking much more time as compared to the other sort of the hard disk drive. So that's the reason that we are not too much, we are not utilizing them in our daily lives. We are utilizing with SSDs. Now, when it comes to the SSD is the solid state drive, and they are basically utilizing the NAND chips, or they are basically utilizing EEPROMs. We have studied about the EEPROM, but we haven't studied about the NAND chips. We will be studying about the NAND chips when you will be doing with paper 2 the Boolean logics. Over here, the data is stored in the form of sectors and tracks. Now, there is the direct access to the data. Direct access to data. Whereas when it was with the HDD, there was serial access to the data. Direct access means it will go to that particular location and it will bring the data back. But when it comes to serial access, so one after the other, and then other is after find out over. Now, direct access is the reason that the latency rate over here is quite low. काफी ज्यादा कम है आपके पास. That's the reason they are fast. There are few other advantages of the SSDs. What are those few other advantages? Now, these are regarding they are more reliable because they are having no moving parts. Okay, they are cheaper. They are considerably lighter as they are not having the magnetic materials in them. Apart from that, they don't have to get up to speed because in your physics you might have done with the terminal velocity and the final velocity. So HDDs were spinning clockwise or in anti-clockwise direction. So that is the reason that they need a particular speed to come up to the maximum speed. Okay? But over here, there is a direct access to that particular thing. So if there is a direct access to that particular thing, so they do not get up to the speed. And if they do not get up to speed, obviously there is no friction, so they will be much more cooler and they will be utilizing less power, or the power consumption will be quite low. As well as there is no moving part or there is no magnetic material, that is the reason that they are portable as well. So we do have multiple benefits regarding, or the advantage regarding the SSDs, but the thing that is having multiple advantages do have a disadvantage as well. Now, the disadvantage over here is with the longevity. Longevity means life. Now, the life of the SSD is quite low as compared to the HDD. Now, the life of the SSD, is maximum of 3 years. If I'm going to write with 20 GB of the data per day up to 3 years. 20 GB of the data, right, means that I'm installing 20 GB of the data on the hard disk drive for consecutively 3 years. That makes up around 21,900 GBs. So that is the maximum life of an SSD. But HDD has no such issue. That is the reason that when it comes to the web servers and all, so we are mostly using the HDDs over there because there is no issue with the longevity. Yeah, they may take time as the latency rate is quite high over there. They may take time to access the data, but you may say that they have no longevity issue. And servers are on the servers. You may say that we are writing multiple of the data on a daily basis. So over here, over there, we cannot afford with the SSDs. Clear with this point, Ryan? Clear? Daniel? Okay. Now coming to the offline storage. So starting with the offline storage, just remember two things, that when it comes to the CDs, they are utilizing the spiral tracks to store the data. Whereas when it comes to the DVDs, they are using the polycarbonated layers to store the data. Always do remember that when it comes to the CDs and DVDs, they both are storing the data in the form of bits and bumps. Now, pits means these blank spaces over here, bumps means the red or the orange area, as you can see them. Okay. So, as much as the smaller the pit size, that means the distance between two bumps, as much as it will be less, the more data is going to be stored. So the pit size in CDs is larger as compared to the DVDs. That is the reason that DVD contains more data as compared to the CDs. Now, to learn this part, what you can do, you can just go through this table. This table is the complete summary of whatever is written over there. Okay, just omit the last part. Now, this type, we do have the CDs, DVDs, and Blu-ray. The laser light through which the data is read from and written to is the red for the CDs and DVDs, but for the Blu-ray, it's blue. Wavelength of the laser light, that means distance between the wavelength of the laser light means distance between the bulbs. Okay, so you may see that when it comes to the laser wavelength of the laser light, so it's 780 nanometers over here. But when it comes to the DVDs, it's 650 nanometers. That means pit size has been reduced. Once the pit size has been reduced, obviously more data will be stored in it as compared to the CDs. And when it comes to the, can you see it now, Daniel? Okay, so when it comes to the Blu-ray, so we do have the wavelength over here, 405 nanometers. So that is the least as compared to the CDs and DVDs. That is the reason that Blu-ray contains the maximum or the highest quality of the data. Clear with this part? Coming towards the disconstruction. CD have the single polycarbonated layer, that's 1.2 millimeter, but when it comes to the DVDs, so they have two layers, dual layering. What do we call it? Dual layering. That's the reason that DVDs, RW, read write, may contain or may perform the read and the write functions simultaneously. Okay, but always do remember that when there are two layers and the laser light strikes over here, so there might be an issue of birefringing. Now, what do you mean by the birefringing? Birefringing means that if there are two layers, okay, and laser light is striking over here, so it might not strike at the accurate location. And if it's not striking at the accurate location, so there will be a data corruption or data loss over here. Okay. But when it comes to the Blu-ray, so again, it's having a single 1.1 polycarbonated layer. And okay, now the layer size is small as compared to the CDs. But the wavelength is also small. That means the bump size is greater over here. That is the reason that you can store more amount of the data over here. Okay, got this point? Got it? Rayan Beta, got it? Okay, now we're coming to the next phase of this topic, that is regarding the computer architecture. So we are done with the two phases, that is with the IO and the memory part. Now we're coming to the next next phase of this topic, and that phase is regarding the computer architecture. Now, computer architecture, you may say that it was basically done by John von Neumann. Just let me open it up. Okay. In 1945, John von Neumann said that I'm not going to consider a system until unless it's not having a memory unit in it. Earlier than that, a system do contain only two things, that's ALU, arithmetic logic unit, that is responsible to perform all the arithmetic like plus, minus, multiply, and divide sort of the things, and logical means less than, greater than, equal to, not equal to sort of the things, okay? And the control unit CPU. But it was not having the memory unit in it. So the other scientist says, okay, if you are just saying that you cannot store, you are not going to consider a system until unless it's not having a memory unit in it. So please give us an architecture regarding that. So he proposed an architecture, and we do have the rough diagram of that particular architecture. This is the rough diagram of that particular architecture that contains the process, that means the CPU. It contains the memory unit in it. It contains the IO devices, the input-output devices, or you may call it as the peripheral devices as well. Now you may see three different lines over here as well. These lines are basically known as the buses. As in the last class, we discussed about the buses as well, that these are the communication path between different components of the system. We do have three buses: address, data, control. We learned about the functionality of the buses as well. Let me divide it for you. Address bus is responsible to bring the address of that particular memory location from where you need to fetch the data or where you need to fetch the data. Data bus is going to fetch that particular data whose address is provided by the address bus. And finally, control bus is responsible to control all the operations taking place in that. Now, except for the address bus, data and control bus are bidirectional, whereas the address bus is unidirectional. Moving ahead, coming towards the detailed architecture for the Von Neumann. Now over here, if you can see that there is an input device, there is a memory unit, there is an output device, there is a processor, and there is a control unit. So you may see that control unit is having two registers in it, the program counter and the CIR. Program counter contains the address of the very next instruction that needs to be fetched, whereas the CIR is containing the instruction that needs to be applied on the data. So control unit is basically controlling the input devices. It is controlling the memory. It is controlling the processor as well as it is controlling the output devices as well. So in short, you may say that it is controlling all the devices or all the equipments or all the components that are within the system. Just hold on, guys. Okay, so now it's the flow of the data. The flow of the data is from the input device. Input device gives the input. It comes to the memory unit. Now there are two registers again, MAR and MDR. MDR may also be known as the MBR. Now that data goes to the processor and it may come back from the processor after the execution with the help of the ALU. It is coming back to the memory. Once it is coming back to the memory unit, now it will be going to the output device, and now after the output device, it's your thing that whether you need a hard copy of it or you are comfortable with the soft copy. Moving ahead, coming towards the most important factor that is regarding the fetch execute cycle. Now, what do you mean with the fetch execute cycle over here? Fetch execute cycle basically contains 6 steps in it. Now, what are those 6 steps? First of all, just have a look over here. Right now, I'm dealing with O levels. The address of the O levels is room number 1. Just after that O levels, I need to be with the AS level, and the address of the AS level is room number 2. After the AS level, I need to be with A2 levels, and the address of that A2 level is room number 3. Okay. So the first step of the fetch execute cycle says the program counter contains the address of the memory location of the next instruction which has to be fetched. Right now I was with O levels. Now after that, which class I need to teach? AS. Very good. So the address of the AS is R2, room number 2. So that will be in program count. Okay. Now this address, because I have now executed O levels, that means I have just taught the O levels. So now this address will be copied to the MAR with the help of the address bus. This address is then copied from the program counter to the to the memory address register. This is done using the address bus. So room number 2 address has been arrived in a MAR. Now right now program counter is empty. Is that so? Great. Now the contents instruction, that means the data that is present on room 2 will be there in MDR using the data bus. Now that data after the MDR will be copied to the CIR. Meanwhile, program counter was empty. Is that so? So after the AS level, what class do I need to teach? So there will be an increment in the program counter by 1, and now it will point to the next instruction that needs to be fetched, that is room number 3. And finally, the instruction will be decoded and executed, and the similar cycle will repeat itself until the entire process has been completed. For this point, Rayan, clear? So we are done with the fetch execute cycle as well. Okay. So just hold on, please. Okay, now they are saying that the execution speed of a system depends on few of the things. That are the cores, that means the number of the processors, these are caches, and these are the internal clocks. Now, internal clock is basically a system clock that is utilized to increase the frequency of the system. Frequency means the time, or you may say the number of the process or the number of the instruction that it is executing in a particular time interval. So if I'm going to increase that system, increase the frequency or increase the speed of the system clock, more instructions will be processed in a particular time interval. If I'm going to reduce them, less number of the things will be, or less number of the instructions will be processed in a particular time interval. So they are saying that apart from the, you may say, apart from the system clock, there are few more factors that are affecting the speed of a system or the execution speed of a system. So number one, it's the bit of the bus. If the bit of the buses are more, so more data will be transferred to the processor easily. Is that so? Rayan? ज्यादा स्पेस होगी, ज्यादा डाटा जाएगा आपके पास, there will be less space, obviously less data will be transferred in a particular time. But there is an issue as well. What's that issue? The issue is regarding the overclocking. What do you mean by the overclocking over here? Overclocking means that if you have increased the number of the executions in a particular time interval more than the limit of that particular processor, so there will be a issue that is known as overheating. That means your system is going to heat up because you have extended the limit. You have gone beyond the limits of the processor, and that will heat up, and once it will be heated up, your system is going to get crashed and your data can be corrupted. Clear with this point? Coming toward the next part, that is regarding the caches. They are saying that the caches can contain more data. Obviously, more data can be processed easily. Then finally, it comes with the cores. Cores means the number of the processors. Now suppose that you are being provided with two processors at a particular time interval. You are being provided with two processors at a particular time interval. So what are you going to do? Just let me draw it for you guys. You are being provided with two processors. Okay. Now the instruction comes in, and this will be divided half into this and half into this. Now these processors need to be synchronized with each other. If they are not synchronized, so obviously there will be no connection between the processors. So how many paths or how many channels do we require to synchronize or to have a communication between these two processors? Single path, great enough. That we will the single path or a single channel. Synchronization means that half of the process was done by this core 1 and the other one was done by core 2. Okay. Now, once the core 1 has done the process, it will be synchronizing with core number 2. Okay, you have done the process as well. Now they will be accumulating the result and providing you the final result. Now, let's suppose that we do have 4 processors in all. Now, how many channels do we require to have a communication or to have the synchronization? Great. One from, let me number it as well, 1, 2, 3, and 4. 1 to 2, one channel, 2 till 4, second channel, 1 till 3, third channel, 3 till 4, fourth channel. Now, third till 2, fifth, and 1 till 4, sixth channel. So the number of the cores, the higher, obviously the channel will be higher as well. Okay. Coming back to the book. Now, these are the things that we need to do from the book. Okay. Okay, so we are done with this part. Now we need to come with the embedded systems. What are the embedded systems? Embedded system, meanwhile, I can explain it to you, or just let me just open it up for you guys. I'm sorry, this book is quite jumbled, so few topics I also don't remember that where are the placed. So coming towards, okay, now here we are. Now, when it comes to the embedded system, what are the embedded systems? Embedded systems are basically, you guys have done with the input output devices, sensors. So what was there in the sensor? That they are taking up the data, they are inputting the data, they are converting that to the digital form, they are converting it in the microprocessor, and then finally they are converting them again to the analog format. And if the data is outside the acceptable range, then a particular action is being performed. Similarly, this is a small system. The sensor, all the working that is being done, that is a small system. Now, this small system is being provided with a particular word that is known as the embedded systems. So these embedded systems or these small systems are placed in a typical devices. Like for example, they have given us an example of a car over here. That this car contains multiple things in it. It's having a entertainment system, it's having a GPS system, the airbags, the EFI, exhaust emissions, traction controls, vehicle security, ABS braking, and all. So these all are known as the embedded system. Okay, now we do have the few benefits of the embedded system. They are not too costly because these are the small systems. Okay, they can be placed or replaced quite easily, but there is a disadvantage as well. Placing or replacing them, they can be replaced easily, but placing and replacing them require a particular experienced person or an expert person. The reason is because if the person is like not experienced with that thing, so if he is gonna change anything with the, for example, with the airbags, so that may cause a malfunction with the vehicle security as well. So these are the drawbacks and the benefits given over here with the embedded systems. You guys can have a look over here, and these things can be asked in your paper easily. Okay, so that was all for the hardware topic. Alhamdulillah, we are done with the hardware topic as well. In the next class, we will be continuing most probably with the softwares. Thank you so much, guys. Allah Hafiz.